Alright, so in this video we are going to learn how to find a image in a concave mirror. So this is our concave mirror right here. And in our setup we have our center of curvature, our focus, our vertex, and our principal axis. Right? So our principal axis is straight across. And really for all of these questions where we're trying to find an image in really any mirror, and especially for a curved mirror, we want to be drawing our reflected lines off of this mirror and finding where they intersect. And so in order to actually figure out our reflected rays, we can use one of these rules to make it a little bit simpler than having to take out our protractor every single time. So number one, any ray that goes through the center of curvature will reflect through the center of curvature. So what that means is from the top of this object, any ray of light that comes through the center of curvature is going to hit the mirror and then go back through the center of curvature. And so let's start with that first ray. So we have our object, we have our center of curvature, and it's going to come straight through. I've not drawn the mirror all the way, so I'll just extend it a little bit. It's going to come through, it's going to hit the mirror, and then it's going to come back. Right? So this ray of light is going to come back in exactly the same path that it came from, but just going off in the opposite direction. And actually I'll even extend it beyond, just in case our image forms somewhere back here. Right? So this ray of light came from here through the center of curvature, hit the mirror, and then came back through the center of curvature. That's using rule 1. Rule 2, any ray parallel to the principal axis will reflect through the focus. And remember, the focus is the point that's halfway between the mirror and the center of curvature, right? So it's right in the middle. And so any ray that's parallel to the principal axis will reflect off and go through the focus. So let's see what that one will look like. So we want to make sure that our line is perfectly parallel with the principal axis. It's coming from the same point. And this ray, once it hits the mirror, is going to come through the focus. Oh, sorry, my ruler moved a little bit there. Let's just make sure it's perfectly straight. Alright, so we've got our first ray going through the center of curvature and our one coming back through the center of curvature, and then we have our ray that's parallel to the principal axis and coming through the focus. Now right now we could be done with the problem, right? So what we can see is that these two reflected rays are crossing right here, and so we could draw our image and we'd be done. But I do want to just show you what these last two rules look like, so that in case there's a problem where maybe this first or the second rule doesn't work, you're not able to draw it, you can see what these other two look like. So number 3 says that any ray that goes through the focus will reflect off the mirror and be parallel to the principal axis. So it's kind of opposite of the second rule. We have a ray coming through the focus, and then that ray, once it reflects, will be completely parallel to the principal axis, right? And so luckily, I took some time drawing this, when we reflect this off, it goes through the same point that these other two did already. If we found that this ray crossed down here, or this ray crossed up here somewhere, it would have meant that we made a mistake somewhere. So our third rule, any ray that goes through the focus, when it reflects, will be parallel to the principal axis. This last rule, you do need to use a protractor, and so it says any ray that hits the vertex will reflect at the same angle that it has with the principal axis. And so what that's going to look like, and again, this is maybe the hardest one to draw, but we'll see that it's actually very useful when it comes to lenses, so that's why I'm including it right now. But you won't usually use this rule for a mirror. Any ray that hits the vertex is going to have the exact same angle once it reflects. And so in order to draw that one, we're going to have to get our protractor out. And so according to this angle is about 15 degrees. And so what I'm going to do is I'm just going to put a little mark on the 15-degree location over here. 15. It looks like it's about right there. And so now I'm going to draw a straight line between our vertex and this point that I have here. And we can see that actually all four lines went through the same place, right? And that's really why, if you're doing it correctly, you only need 2 of these rules, right? Because all 4 will intersect at the same place. All right, so now let's draw our image. So our image is going to start from the principal axis, right? So this point here corresponds to this point here. And now it's pointing downwards. So our image is pointing downwards. And now we can figure out what the SALT of this image is, right? So the acronym SALT. So the size, you can tell it's definitely smaller, right? If you don't believe me, I'll take out my ruler. And this part is about 2 centimeters tall, whereas this arrow is about 1.5. So it's definitely a smaller image. Attitude. So attitude has to do with whether it's right way up or upside down, and this arrow is pointing downwards. So this one is definitely upside down. The location. So there's 2 ways really that you can explain this. The first way is that it is closer to the mirror than the object. Another way you could say it is that it is between the center of curvature and the focal point, right? So those are 2 different ways to describe the location. And then the type. This is either going to be a virtual image or a real image. Now if we look at this image, we can see that it's formed by light rays that are actually bouncing off of this object. What that means is that it is not virtual. It is a real image. If we put some kind of a projector screen or something there, we would actually be able to see that arrow on our screen. Whereas if the image was somewhere back here and we drew it with dotted lines, in that case it would not be a real image, it would be a virtual image. But for here it's made with actual lines, with actual rays of light, and so it's a real image.